Okay, so pyramid you said was a 3D triangle. Where do you see pyramids? Egypt. Okay, anywhere else?
Paris.
Paris? Define Paris. I know where one is in Paris, but...
What's that art museum?
The art museum, the Louvre.
Yeah.
Yes. There's a very, very famous one right outside the front of it. Uh-huh.
The big one with the little one.
If you think about it, the Eiffel Tower is also a pyramid.
It is.
Just not enclosed all the way, right? But if you think about the Eiffel Tower itself, it is a pyramid. So one of the places that I love to visit is Vegas, and there's pyramids there too, because not only at the Paris Hotel and Casino there is a Eiffel Tower there, but also the Luxor Hotel is a pyramid. And next week, after we get done with the volume of stuff, I'm going to actually give you a worksheet specifically on the Luxor. Okay, so that way you have one, and then I'll pull up pictures, because when I was there the last time, I actually took pictures of the inside of it so you guys could see what's inside, and it pertains to the worksheet. So just so that you guys know, that'll be next week when we get onto that, and then like I said, shortly after that, then we'll be done with the worksheets and then getting into our projects. So the pyramid formula, bless you. For the surface area of a pyramid, you're taking 1/2 PL plus 1B. Now I know all those letters mean different things. This is one of the reasons why I wanted to make this, so that people knew what was going on. But remember, P stands for perimeter, which means the distance around the pyramid. Okay? So for example, if you were in Vegas and had time to kill, and we're down at the Luxor Hotel and thought, you know what, I'm going to walk around the outside of it. That's what you'd be doing, is finding the perimeter of it, right? Just walking around the outside. Okay? The L, this does not mean length. The L is not length. The L is what we call the slant height. A number of years ago, there used to be a show on NBC called Fear Factor. Have any of you ever heard of it before?
Yes.
Okay.
I hate it.
And one of the episodes that they had on that, and I never really watched the show, but I did watch this one because it was Fear Factor Vegas. And one of the things that they had to do is they had to slide down the sides of the Luxor Hotel and grab as many flags as they could on their way. Okay, so they were sliding down the glass. It's all glass, right? So imagine that they had something on their backside that left a streak behind. Whatever that happens to be. Right? That's what they mean by slant height. It's like from the top of the pyramid, and in that hotel, for instance, it's a big light. You can see from space. Imagine if you were to take from that light and drop a line straight down the side all the way to the edge. Okay? So I'm going to draw one so that you can see it, where it should go. And I'm going to draw specifically I should better put L slant height. And then big B is area of the base. And that 100% depends on what kind of base it is. So for instance, if it's a square-based pyramid, like the Luxor Hotel is, or like the ones in Egypt are, then it could be that. It could be a triangle-based one. I've seen pentagon-based ones, hexagon-based ones, they're all there. So B just stands for area of the base, whatever that happens to be. Okay? So when you're looking at it, and I don't have enough room there, so I'm going to draw one here. So when you have a pyramid, many times it's drawn like so. And like you guys were trying to tell me, it's a 3-dimensional triangle. Okay? Then the other thing is that some of the questions are, why are there shapes underneath? The shapes underneath are usually done in dotted lines, and the reason why they're in dotted lines is because they're there. You're just not supposed to be able to see them. Like if I was looking at the pyramid from the side view, this is all I could see of said pyramid. However, we know that there's other sides, right? Should be. So what happens is that we use these dashed lines like this in order to show and to replicate that we have the rest of the pyramid on the back side. We just can't see it. That's what those dashed lines are for. Okay? So that's what the pyramid is going to look like. Now, in different color, a couple different things that you need to also know. Not so much today, but when we get to the volume of this. Imagine if there was a line that went straight down from the top all the way through to the center. That is known as the height. Okay? So if you were dropping a line straight from the top of the pyramid right through the center to the basement, that would be the height of it. Okay? Then you have lines that go out like this. I better not put it in black. Let's put it in brown. You have a line that goes out here. And then you have the streak line that goes down the side. This down the side, the red one, would be considered the slant height. Okay, that's the slant height. Now, the reason why I drew that brown one in there as well is because I wanted you to see between the blue, the red, and the brown line, what shape did I create inside the pyramid? Yes, I created a triangle. More specifically, what kind of triangle? A right triangle. And how do you find missing sides of a right triangle? A squared plus b squared equals c squared, or the Pythagorean Theorem. So for instance, on this particular thing, on this particular model, especially if it's a square-based pyramid, this brown line is half the distance of the base, or half the distance of one of the sides. So if the side was 10, the brown line would have been 5. Okay? Then, if I know the height, I can find the slant height by simply doing a squared plus b squared equals c squared. Or in this context, h squared plus half the base squared, or half the base length squared equals l squared. So you may have to use the Pythagorean Theorem. I think on this worksheet though, all of the ones have the slant height listed for you. It's the ones later on that we're going to have to do that for. Okay? So, again, for this particular thing, what they're going to do is they're going to give you a shape and ask you to find, it says lateral area and surface area. Make sure you just find the surface area. That's all I care about. Cover the thing, okay? So for instance, in glass, if I was doing the Luxor Hotel and Casino, all that stuff would be glass except for the bottom, because that's what it is. If you've never seen it, I'll pull up a picture of it next week when we do the worksheet, okay? So on something like this, let's say that this is 20. And then this is, so it's 10. Let's say this is, the slant height is 24. And that's all we need when we're coming up with the different parts of it. So if I just give you 20 and I tell you it's a square, what's the distance around it if each side is 20? How do I find the perimeter? Just add them. 20 plus 20 is?
40.
Plus 20?
60.
Plus 20?
80.
80. So the perimeter for this one would be 80 times the slant height, which is how much did I put? 24. Divided by 2 plus, and if I told you it was a square-based pyramid, that means it's a square base. How would I find the area of the base?
Multiply both sides.
S squared, or 20 times 20, or whatever you want to do. So for our problem, what I need to know is, I need to know what 80 times 24 divided by 2 is, because that's 1/2 PL, plus 20 squared. That's my answer. So a half of 80 times 24 is how much? Anybody know? 960 plus 20 squared is 400. Good. And what's 400 plus 960? 1,360. And then depending on whatever unit I have it in, right? If it's feet, then it'd be feet squared. If it was miles, miles squared, whatever. Okay? What do you guys think about the pyramid?
Good.
Not too bad? Again, it's the perimeter, so the distance around the outside, times the slant height, which again is that distance along the side. Not straight up and down, and not on the edge. If you notice, it's not part of the edge, it's straight down the side. One of the sides, okay? And then plus a base squared. And if you notice, it's not 2 b's, it's only 1 b, because there's only one base. There's only one bottom. Okay? Unless you're at the Louvre, which is then inverted. So the tip is at the bottom. Okay? But that's the pyramid. Do you guys want me to do another one?
Okay.
Okay? Then, the next one, and last one for today, cone. Okay? For the cone formula, for this one, what makes a cone different from a pyramid, first of all? Do you guys remember? It's got a circle bottom, okay? And then there's no sides, is there? It's just got a circle bottom. So when we draw those, and I can fit that one in here because there's not much, ooh. Can't have that. It almost looks like I'm drawing a, good Lord, that's ugly. It's almost as if I'm drawing a triangle to begin with, except for now, instead of making the triangle finish, I'm going to round this bottom. And then when I make it three-dimensional, I make the bottom part dashed, or the back part dashed. That's how you know it's a cone and not something different, okay? Then, again, to put them in the same colors, this line straight down through to the bottom would be the height. This line out here could actually be representing the slant height because of the fact that it is on one of the sides, because there is no real side. And then this right here is called a what? What's the brown line called? Huh? A radius, right? Again, what kind of shape did I just create with my blue, red, and brown? A right triangle, which means I could end up using the Pythagorean Theorem again. Okay? But I do create a right triangle out of that. Now, my surface area for a cone is pi r squared, which, what's pi r squared the same as? Like, what is that? What area formula is that for? The circle. So it's telling you basically the area of the circle. So the bottom. Or the base, right? Plus pi r L. And what's L stand for? Slant height. So it's the slant height, not a length. So for this one, and if I'm looking at the right ones, if I were to give you a radius, let's say the radius is 5, and the slant height is 13, could you find the area of the cone? How much waffle do I need to have in order to make my waffle cone, right? If you're working in a place that sells waffle cones. So, again, pi times, what's the radius? Squared plus pi, and then the L would be
13.
Now, I noticed, and I don't remember if it was somebody in this class or if it was in the last hour, but some of you were doing this. For this particular problem, you'd have 25 times pi. Some of you, and I don't remember who it was leaving it as 25 pi, which is not wrong. Okay? And then 5 times 13, does anybody know what 5 times 13 is?
75.
Not 75. 65? So then if I add those together, I get 90 pi. And I don't remember who it was on one of the worksheets because I did them the last hour. That's how you left the answer. And that's perfectly fine. Okay, that is the right answer. I mean, it is an acceptable answer for this where it says 90 pi. What's the area? 90 pi. Good. But typically I don't go walking around and say, go, the area of that cone, 90 pi, right? We usually have something else, or we might not even estimate it. So if you leave it as 90 pi, I'm okay with that. I'm also okay with if you take 90 times 3.14 and tell me what that is. Make sense? Okay. And again, I didn't put any measurements on there, but if there was measurements, then it would be whatever that is squared. On the worksheet, it will say lateral area and surface area. Just find the surface area, the total area. Do not find like the little part, like the sides, and then find the base with it. Just find the whole thing, because you got to do it anyway. Like this, if I was looking at the formula, this is really the lateral area, or the cone part, and then this is the base, and then you add them together. You got to find it either way. You have to find it. Okay? What do you think?
Okay.
Then tomorrow, just so that you guys know, after today is surface area of these two shapes. Tomorrow, I'm going to backtrack and go do volume of prisms and cylinders. Monday, we'll do volumes of cones and pyramids. Tuesday of next week, I got a worksheet on the Luxor Hotel itself, where we'll do some stuff just based off of that. Wednesday, we'll do a worksheet on spheres, because that's the last three-dimensional shape that we have, right? A sphere. And then I haven't 100% decided what I want to do Thursday and Friday of next week, because it's getting to that point where either I got two different options and I haven't decided which one I want to do yet. So, Katie.
I would do that one.
Absolutely. All right, so